I'm Zach. I work at Skip. I'm the lead engineer on the Skip API team. Skip API is it's our main goals is to make it the UX very friendly for transferring tokens and swapping tokens across different chains. I think there's we have lots of various integrations, Kepler, Leap, Stargaze, and IBC Fun is kind of our home application where we try to show off all the cool stuff that where we can transfer our tokens and how easy we can do that. The reason I want to give this talk is I think in building the Skip API, we made a lot of learnings working with all of the different interchain protocols, especially composability between these protocols. So I would say for most interop protocols, IBC, in principle, they're kind of simple. I have tokens here. I want tokens there. But the details are confusing. And oftentimes, if everything lines up, the details don't matter. But when they do, you often just get stuck. And it's basically completely impossible to, well, it's not impossible. You just have to, research to figure out how to unstick yourself. And then the other side of this is composability, which even when the protocols are working perfectly, it kind of sucks to have to execute tons and tons of transactions. I know when I came into Cosmos ecosystem, I actually loved IBC. I found the UX so amazing because I was comparing it to bridges in other ecosystems. But still, it was like going to Osmosis. You click a button to withdraw, click another button to swap, click another button to withdraw. Deposit was the first one. So this was definitely one of the things that we wanted to see improved. And luckily, Cosmos has great middlewares that exist to help improve this, but they come with their own caveats that make them complicated to use as well, especially when things go wrong. So we'll talk about that. So interoperability problems with IBC. The first one is that one of the details that most of us who use IBC don't actually even pay any attention to anymore, especially, is that you're sending over a channel, and there's multiple channels, sometimes between the same exact chain. So between Atom and Osmosis, or Cosmos Hub and Osmosis. And if you send over the wrong channel, you basically just get a token that's useless. So there is like a preferred channel, and that leads into the second situation. It's completely unclear like how you would actually determine what that preferred channel would be. And then lastly, it's not really a problem with the protocol itself. I think most bridges are going to have this problem. They're going to be limited to like whatever ecosystem they exist in, and but that from a user's perspective, that is kind of a problem because they want to go where they want to go and they don't care where your bridge is supported and where it isn't. So some of the solutions that we went with for IBC was I'm not sure if this was wider, but we were calling it token unwinding. And our solution to that was for all the Cosmos chains that we support, we actually index all of the IBC channel data from all of those chains and all the token data. And we build a graph that says how to get from one token to another token. This doesn't include swaps. This is just like how do I, IBC, like two tokens that are like IBC transferable between each other. Like how do I get from one to another? And this allows us to figure out like how to do like if you have to do like 3 different hops to get from one token to another because it's kind of wound up in another chain. If you're on Neutron and you want to send your Atom to Osmosis, for example, you first have to send it to Cosmos Hub and then you could send it to Osmosis. And so this graph was our implementation for how to expose that route to the user. But the second thing is even like if we know the channels, this sort of assumes that you already have figured out that second problem, which is you need to know what channel to go over in the first place to get the right token. And that's sort of equivalent to saying you need to know like the name of the token on the destination chain. Because even though in all the UX, we display it as Atom, it's not called Atom on the chain. It's called like IBC like 12345 or something, right? So you're not. So the way that we approach this is we just heuristically have an algorithm for figuring out what that token is. For the most part, it's really simple. So shorter paths are better, higher liquidity tokens are better. And that works like 95% of the time, maybe 90% of the time. And then we find out we kind of analyze and figure out like the cases that it doesn't work. And then we hard code the exceptions in. And it seems, mostly because this is definitely one of the complaints that we get the least complaints about is that actually works pretty well for, to get users to where they want to be. And then the last part of the problem, which is that IBC is limited to the Cosmos ecosystem. For some people, that's not a problem if you want to only operate in the Cosmos ecosystem, but many of us have liquidity on other chains that we would like to get access to. And so this is, I think, one of the core things that I care about mostly when thinking about it from a Skip API perspective is composability with alternative bridges. And, this we'll extend this to, composability with, lots of different interchain operations and even non-interchain operations. And so in that, let's talk about some of the other bridges that we interop with. Axelar also has some of its own problems. One of the problems is it's kind of hard to work with native tokens, on EVM chains. There's a couple of things. Is I think usually when you transfer, you end up with like wrapped ETH, but if you end up on a chain and you don't have the fee token, then that kind of leads to problems. And so we have some solutions around that. And then I've always found like the way that fees work pretty confusing. I haven't really seen a bridge that has fees and they don't work in a confusing way, but hopefully one day we'll get there. The two kind of problems are one is sometimes the fee comes on top of the amount that you're sending, and other times it gets deducted from the amount you're sending. So that's the difference between sending 10 and receiving 11 or sending 10 and receiving 9, right? Like, I got that wrong, but you're either paying on top of the amount you're sending or it's getting taken away, and it's confusing when you're supposed to do which. So we support native tokens by a composability primitive that Axelar actually does support, which is calling a contract after you do a transfer. I think this is a pretty standard way to solve this. And this works great for chains like Ethereum, Polygon, where you're transferring like native ETH, and then you just want to wrap it into. You're transferring wrapped ETH, and then you just want to unwrap it to ETH. This has a shortcoming on chains like Base, where what you end up with is actually an Axelar wrapped like Ethereum, and there's no there really aren't liquidity pools to swap for that to Ethereum with like sufficient liquidity. So it doesn't get us all the way there, but it gets us most of the way there. And the way that we are hoping to solve the latter case is through better support for swapping on EVM sides, that you would basically just trade into a token that actually has better liquidity. And then the other way that we solve this is actually just displaying fees in a consistent way in the API, even if the reality is a little bit different. So Skip API tries to always say that you're paying, if you're sending 10 USD, the fees come out of that 10 USD as opposed to being added onto it. The only exception to that is if you're paying in a different token, then we try to just like display that message. Our API has a message that front ends can use to display. In IBC Fund, we display that message just to say, by the way, there's like a bridge fee that's associated with this. Then CCTP is another bridge that we also integrate with. The main one I want to point out here is also a problem technically with IBC, which is that relaying is not like really properly incentivized within the protocol itself. And so we have like kind of external Incentivizations. The real problem, though, with CCTP is that relaying is poorly incentivized and it is expensive. So if you're bridging to Ethereum, you're going to be spending quite a lot of money doing that. So just kind of interoperability roundup. We, there's too much effort to figure out like which tokens are solved. This can be solved through registries, that kind of thing. Relayers need better incentives. Ideally built into those incentives built into the bridge, and bridges should extend their reach by making composability far easier. Just to kind of click through here, composability for IBC, the two main tools that we use. There's other ones depending on the chain you use, but is packet forward middleware, which was created originally by Strangelove, and IBC hooks. PFM allows you to trigger another IBC transfer when an IBC transfer is received. IBC hooks allows you to call a WASM contract. And these are the main primitives we use to do like a transfer, a swap, and then a transfer all in a single transaction. The thing that doesn't work great is that Cosmos, everyone kind of gets to pick and choose like what they integrate with, and so not everybody supports these middlewares. And so there is some extra work involved in making sure that we do this. The second part is when you have a memo for middleware that fails, it fails silently, which is really, really confusing to users. Whereas like if you have malformed metadata, what you'd really like to see is it just like fail and then so that you can back out. So Skip API solves this by indexing those composability solutions, and we automatically use them when we detect that they're supported. And when they're not supported, we just make the user sign multiple transactions. But you can actually disable this behavior, and it would just return no route. So depending on, for the use case, like what the better user experience is. But on IBC Fund, we can sign multiple transactions, which is nice. And then we also generate the memo fields so that it's not implemented separately in every single client. And so this, I think, adds some consistency to hoping that this is going to work. But really, I think the solution here is something in protocol that like fails more gracefully when problems occur. Axelar has composability problems of itself, like when you call a contract on the destination chain, because it has GMP, which is similar to IBC hooks. Funds just sort of get stuck in the bridge until you upgrade the contract or fix it, or until the contract succeeds. And there's no way to back the transaction out, which, in the worst case leads to permanent loss of funds. In the best case, is very annoying. And so we have a wrapper contract, which basically can't fail. And then, it sends money to a recovery address when that occurs. Last one is CCTP. Really, the problem here is that CCTP within Cosmos has minimal composability. Noble is currently working on offering better composability for us. But this basically just results in us having to use multiple transactions when we work with CCTP. I think there's better primitives are coming to Noble. Noble forwarding, auto CCTP, as those get added, will integrate. Hopefully that will be a better experience for Cosmos, because I would love to be able to transfer, IBC transfer, swap, do all that kind of stuff just like we can for these chains. And then for the roundup for composability, the main things is for composability primitives, like failure should not be silent. Failure should always be recoverable. This core composability functionality should not be optional. Like PFM and IBC hooks, I think, are pretty fundamental to how to bring UX into a better place. And then lastly, composability is I think just central to bridge UX. I think if you're building interop protocols and things like that, I think focusing on making sure that your thing is composable with others is the way to go. And that's all I got today. If you have any questions, I'm not super active on Twitter, but that's I'm sure if you, I at least lurk there. So if you message me, I'll see it.
said you don't think IBC hooks should be optional, but IBC hooks requires cosmosm, right? Isn't cosmosm optional?
Yes. That is a complexity. Oh yeah.
There we go. Okay. You're absolutely right. Cosmosm is optional.
Shouldn't be.
Shouldn't be. There you go. No.
Go, the bastards.
Yeah, I would love to see something like IBC hooks to even just make a wider variety of calls, and maybe not just WASM calls, maybe things that operate at the module level, and maybe that would make more sense in a Cosmos ecosystem. Luckily, like since I'm mostly dealing with WASM for swapping, like that's sufficient for my use case. But yeah, there's perhaps something else that could be made non-optional. But in that case, yeah.
I mean, I definitely feel pretty strongly that if you're going to have something not be optional, it needs to be SDK native, and Cosmosm isn't.
Absolutely.
Oh, hey, as an engineer working on Skip API, by the way, thank you for awesome API. Do you feel like you would want to be able to do like local integration testing and kind of simulation so that you're not, because like test nets, I think it's actually a bad word because it's not really testing, it's still production. Do you feel like that's an experience you want as a developer? Is there some impetus on teams to maybe do that as a corollary potentially open source?
Yes, test nets are, especially in these like complex like multi-chain setups, are actually kind of problematic because they they often aren't maintained nearly as well as prod is, and so you often can't find liquidity to test swaps. You often can't find the bridge type that you need, especially that's composable with whatever else you're doing. Setting up a local testnet or test sort of interchain would probably be the better solution. The challenge and the reason why I think we haven't tackled it quite yet in a complete way is that we're actually dealing with so many kind of different situations and different chains that have different like sets of middlewares, and it's kind of unclear on how to like get something like sufficiently rich in like a testnet situation. Yes, very rich.
Yeah, thank you for the talk. Just wanted to ask about your thoughts on the drawbacks of IBC hooks, if any, in your opinion.
It's definitely other people on my team that know a lot more about this topic than I do. So I'm unaware, though. Actually, the main one that comes to the top of my head is that when you're actually executing a hook after a relay, is that the relayer is paying the gas for that execution. And since there isn't like really proper incentivization for IBC relaying, it does seem like that is perhaps like an attack venue for people, and could like degrade relayer performance. But it seems like we haven't really seen that yet. But that's perhaps one of the downsides that immediately occurs to me. Yeah.
One thing I've been beating the drum about since 2021 is I would love to see like a native unblind handshake in the IBC protocol, such that every token is always one notional hop from its home chain. Is that a thing that like we are reaching a point where maybe we could do?
Possibly. Like, I mean, I think there's a lot of complexity around with, especially as the number of chains grows, like the notion that we'd always be able to be like one hop from the home chain. I know that there's definitely people working on protocols out there that, kind of solve this like, a quadratic blow up of chains that, all referencing each other. But, it's not something that I've thought super deeply on. Yeah.
As the number of bridges is like growing, now we have composable and union and wormhole and nomic and all this stuff growing, right? Like eventually this might grow beyond the capacity of the Skip team to do all the integrations. Will there be a path for external like integrations?
Yeah. that's one of the main things as internally we're kind of talking about right now is like extendability and pluggability for the Skip API. I think as the number of bridges increases, like that creates a number of problems. I do kind of find ourselves potentially in a situation where there's going to be like some bridges that are just like have better composability and better UX, and like those might just take over, and like some bridges will die. But if we do end up in this world of like tons and tons of bridges, then I think extendability is definitely very important for our future.
Thank you. So when you said that it was tough for you to verify channels for like a correct token delivery, so what's I guess like your guys' approach to being able to more easily verify state channels?
So we do verify with the light clients on a regular basis to ensure that the channels that we recommend people send IBC tokens over are good. I think the hard thing is more from the user perspective of like they have to choose channel 1, channel 2, and even like both of those channels can be like good and active and light client verified and regularly updated, but like one of those channels is the correct channel and one of those channels is the wrong channel. That's where we kind of like fall back to like recommendation. But from the state perspective, that's actually not too bad. It is verifying that the channel is like up to date and that it's actually representing the chain that you expect it to. That's not too much of a problem.
All right, thank you everyone.